All right, today we are going to begin with the derivative of logarithmic functions. We'll be using all the rules that we have studied in earlier classes, along with some of the formulas for the derivative of logarithmic functions. Before we begin, here we have four important formulas that we need to know before we get into the examples. The first one, look at this one, derivative with respect to x of log with any base b of x is equal to 1 over x log b. That is when x is positive, when x is greater than 0. So you know that when x is greater than 0, this function log with base b of x is well defined, because the argument of the logarithmic function must be positive. So in that case, the derivative is equal to 1 over x log b. Now, if you take the special case, if the base of the logarithm is e, then log with base e is written as log x. If you look at this one, and if b is equal to e, okay, if the base is e, then log with base e is natural log x. So the derivative of natural log x will be equal to, if you look at here, we have 1 over x, which is already there, and log b, because b is equal to e in natural log of e is 1. So 1 times x is x. That's why it is equal to 1 over x. So derivative of natural log x is 1 over x when the argument is positive. And if you look at the graph here, this graph in red is the graph of the function y equal to natural log x. And the derivative is the reciprocal function 1 over x. And this one in blue is the graph of the derivative function y prime, that is the derivative, is equal to 1 over x. That is the case when x is positive. You can see I'm only considering the positive part of the x-axis because my domain is x greater than 0. Now the second case, if we are calculating the derivative with respect to x of log with any base b of absolute value of x. When I say absolute value, you can take positive value or negative value, but when you take it as the absolute value, it will be positive, because the argument of the log function must be positive. That is equal to 1 over x log b. Same formula, but note one thing, you are taking the absolute value, so you can take everything from negative infinity to infinity. But if you look at the formula here, it's 1 over x. So you cannot have 0 in the denominator. So the only restriction here is x cannot be 0. Now, that is the general base b. If you take the natural log, meaning of that is when the base is e, the same formula will change to natural log of the absolute value of x is equal to 1 over, so this will be e, b will be e, log e is 1, 1 times x is x. And this is true when x is not equal to 0. If x is 0, 1 over x is undefined. And you can clearly see the graph here. The graph of natural log of absolute value of x is this function in red. And the derivative 1 over x for everything except x equal to 0 is the function here in blue. That is the reciprocal function 1 over x. So in this slide, what we have seen is we look at the general formula to find the derivative of the general log function with any base b, and also the derivative of the natural log function along with their graphs. Remember one thing, if nothing is said about the value of x, then we consider that x is positive. We consider that x is greater than 0, and we apply the formula. So meaning of that is first two formulas here, that is the derivative of log with base b of x is 1 over x times log b, and the derivative with respect to x of natural log of x is 1 over x. These are the key formulas that we need to remember while solving any problem. In that case, we are always considering that x is positive. Example, find the derivative of the following functions. In part A, we have to find the derivative of y equal to natural log of x squared. Now, if you look at this function, y equal to natural log of x squared, you can clearly see that there's an inside function which is x squared and outside function is natural log. So when you have the outside function and inside function, you have to use the chain rule. So the derivative will be dy over dx is equal to, if you use the chain rule says the derivative of outside function, that is derivative of natural log, which is 1 over x. 1 over, in place of x, I have x squared. Then multiply by the derivative with respect to x of the inside function. Inside function is x squared. So if we simplify this, the derivative dy over dx is equal to 1 over x squared multiply to, now the derivative of x squared, you can use the power rule. That is, you bring the power down and reduce the power by 1. So 2 down, reduce the power by 1. So 2 minus 1 is 1. So that becomes 2x. So if we simplify this, dy over dx, the derivative of y with respect to x is equal to, when you divide here is x and it is x squared. So you can cancel one of them. You'll have 1x in the denominator. And in the numerator, you'll have 2 times 1, which is 2 over x. So 2 over x is the derivative of the function y equal to natural log of x squared. Now let's work on part B. In B, we have y equal to natural log of 7x to the 6th. It is very similar to part A. You have inside function of 7x to the 6th and outside function of natural log x. So because you have the outside function and inside function, you are going to use the chain rule. So the derivative dy over dx is equal to, according to chain rule, first we need the derivative of outside function. Derivative of natural log function is 1 over x. 1 over, in place of x, I have 7x raised to 6. Then multiply by the derivative with respect to x of the inside function. Inside function is 7x raised to 6. So this will be equal to dy over dx is equal to 1 over 7x raised to 6 multiply to, now if you want to find the derivative of this one, 7 is multiplied to that function, 7x to the 6. So 7 is a constant multiple, so you can take outside 7. Then multiply with the derivative of x to the 6. So derivative of x to the 6, we can use the power rule. So 6 will come down and we reduce the power by 1. So 6 minus 1 is 5. Now when you look at this one, this expression carefully, you have a 7 in the numerator, 7 in the denominator. Everything is in multiplication. So you can cancel that because 7 over 7 is 1. So that becomes 1. Then after that, you can see you have 5x in the numerator and 6x in the denominator. So 5 of them will get canceled. You'll be left with 1x in the denominator. So it will be dy. Let me use the proper color here. I'm using black for this. Okay, so dy over dx is equal to, in the numerator, we have 6 multiplied to 1, which is 6. And then in the denominator, as we cancel these two, you're left with 1x. So 6 over x, that is the derivative of the function y equal to natural log of 7x raised to 6. Part C now. In part C, we have y equal to natural log of, you can see we have natural log of x minus 1 over x plus 1. So you can clearly see you have an inside function, which is x minus 1 over x plus 1. And there is an outside function of natural log x. So whenever you have the inside function and outside function, we use the chain rule. So the derivative will be dy over dx is equal to, so when you use the chain rule, it is the derivative of outside function. Derivative of natural log is 1 over x. That is, whatever x is here, that will be the reciprocal. So here we have the natural log of, this is my x. In place of x, I have x minus 1 over x plus 1. The reciprocal or 1 over x will be, when I say the reciprocal of x minus 1 over x plus 1 will be x plus 1 over x minus 1. We flip it. That is the reciprocal. That is 1 over x, which is the derivative of outside function. Then multiply by the derivative with respect to x of the inside function. Inside function is x minus 1 over x plus 1. So in this step, we use the chain rule. Okay, so next step will be dy over dx is equal to, here we have x plus 1 divided by x minus 1 multiplied by, now here you can see we have derivative with respect to x of this quotient because you have numerator over denominator. And if you remember, whenever we have numerator over denominator, we use the quotient rule. Quotient rule says denominator, which is x plus 1, multiplied to the derivative of numerator. If you look at the numerator, we have x minus 1. Derivative of 1 is 0. Derivative of x is 1. So we are multiplying by 1. So what we did, denominator times the derivative of numerator minus the numerator. Numerator is x minus 1. And we have to multiply that by the derivative of the denominator. In the denominator, I have x plus 1. Derivative of 1 is 0. Derivative of x is 1. So 0 plus 1 is 1. So I am multiplying by 1. Divided by the square of the denominator. In the denominator, I have x plus 1. So when we square it, we write x plus 1 squared like that. Okay, let's continue this simplification. Dy over dx is equal to, here we have x plus 1 over x minus 1, then multiplied by x plus 1 multiplied to 1, that is x plus 1. Then here we are distributing this negative, so that will be minus x, and then negative times negative will be positive 1. And when you multiply the entire result with 1, that's what you'll get. Divided by, in the denominator, I have x plus 1 is squared, which can be written as x plus 1 times x plus 1. Now you can see a couple of cancellation here. In the numerator over here, I have x plus 1. Here is also x plus 1. So x plus 1 over x plus 1, that is 1. So that get cancelled. And also here in the numerator, you can see there is positive x and here is negative x. So those two x get cancelled. So we are left with, let's see what is remaining. The derivative dy over dx is equal to, if you look at the numerator, this is already cancelled. These two are cancelled. Here we have 1 plus 1, 2 times 1, that is 2. And then in the denominator, if you look at the denominator, we have x minus 1 here, and here is x plus 1. So x minus 1 times x plus 1, if you remember the formula, factoring formula for the difference of squared, a minus b times a plus b is a squared minus b squared. So if you multiply these two, or if you FOIL those two, you should get x squared minus 1. X squared minus 1. So dy over dx equal to 2 over x squared minus 1. That is the derivative of this function y equal to natural log of x minus 1 over x plus 1. Part D. In part D, we have y equal to 7 multiplied to log with base 5 of x to the 4 minus 2. So the derivative will be dy over dx is equal to, now if you look here, this 7 is multiplied to the function. So a constant multiplied to a function, that constant will remain in front. You don't have to worry about that. 7 times, and after that we have log with base 5 of x to the 4 minus 2. Now you can clearly see it is not like this one, log with base b of x. We don't just have x, instead we have x to the 4 minus 2. Meaning of that is there is the inside function and also the outside function. Whenever we have the inside function and outside function, we use the chain rule. And chain rule says the derivative of outside function first, keeping the inside same, and then multiply by the derivative of inside function. So if I want to write the derivative of this outside function, log with base 5, log with any base b is 1 over x log b. So it will be 1 over, in place of x, I have x to the 4 minus 2. And then we have to multiply in the denominator by log b. So it is natural log of b is the base. Here my base is 5. So log 5 is a constant number. Remember that. So that is the derivative of outside function. Now we have to multiply by the derivative with respect to x of the inside function. So here I use the chain rule. Chain rule is used in first step. Also, I use the constant multiple rule. If you remember that 7 is a constant, so it will remain in front. Okay, let's continue our simplification. The derivative dy over dx is equal to, you have 7 in the numerator, so 7 times 1 is 7. And in the denominator, the constant is natural log 5. So we'll write that constant first. Natural log 5 multiplied 2. Here we have x to the 4 minus 2. Remember, it is natural log 5, then multiplied 2, x to the 4 minus 2. Then times, now we need the derivative of this one. Derivative of 2, a constant is 0. And the derivative of x to the 4, we use the power rule. We bring the power down and then reduce the power by 1. So it will be 3. Then after that, we have the last step, almost done. Dy over dx, derivative of y with respect to x equal to, now here we have 7 multiplied to 4x cubed. 7 times 4, 28. 28x cubed divided by natural log of 5 multiplied to, remember this is multiplication, multiplied to x to the 4 minus 2. So that is the derivative of this function, y equal to 7 times the log with base 5 of x to the 4 minus 2. Okay, part E, we have y equal to sine x multiplied to natural log of, look at this one, we have sine squared x, meaning of that is sine x times sine x. So I can write like this, sine squared x. So y equal to sine x multiplied to natural log of sine x squared. Okay, so sine squared x is written as sine x quantity squared. Meaning of sine squared x is sine x times sine x, which is same as sine x, the quantity squared. So here we have two functions in the form of product. My first function is sine x. Second function is natural log of sine quantity squared. So because it is in the form of product, we are going to use the product rule in first step. So that will be dy over dx is equal to first function sine x multiplied to the derivative of second, derivative with respect to x of natural log of sine x quantity squared. So first function multiplied to the derivative of second, plus second function is natural log of sine x quantity squared. Second function multiplied to the derivative of first, derivative with respect to x of sine x. So that is the product rule. First function, derivative of second, plus second function times the derivative of first. Now this sine x as it is, sine x, then multiplied to, now if you look at this one, this is beautiful now. See, we are calculating the derivative with respect to x of natural log of sine squared. So there is an inside function, which is sine squared, and there is an outside function, natural log. Whenever you have the inside function and outside function, you use the chain rule. So chain rule says derivative of outside function, keeping the inside same. So outside function is natural log function. Derivative of natural log is 1 over x. So that will be 1 over, in place of x, I have sine x quantity squared. Sine x quantity squared. Then multiply by the derivative with respect to x of the inside function. Inside function is sine x quantity squared. Sine x quantity squared plus natural log of this one, sine x quantity squared. This is same as sine squared x. Let me start writing that back like this one. Then multiply to derivative of sine x is, if you remember from the previous class, it is cosine x. So here we use the chain rule, and here we use the derivative of sine x as cosine x. So next step, if you look at this one carefully, here is sine x. In the denominator, we have sine x squared, meaning of that is sine x times sine x. You have two of them in the numerator, one of them in the numerator, two of them in the denominator. So when you cancel, you'll be left with 1 sine x in the denominator. So that can be written as 1 over sine x. Then after that, we have derivative with respect to x of sine x quantity squared. Now you can again see that your outside function is a power function, inside function is a sine x. So you have to use the chain rule again. Now when you use the chain rule here, use the power rule first and then the derivative of inside function. So when you use the chain rule, we bring that 2 in front, the power in front. So we write that 2 first, 2, and we reduce the power by 1. You have sine x power 2. Now you have a power 1, which is just sine x. Then multiply by the derivative of inside function, derivative with respect to x of the inside function. Inside function is sine x. Then after that, we just have to copy that. Okay, now after this, what is going on here is we have sine x in the denominator, sine x in the numerator. They get canceled. So after you cancel that, you have 2 left here. So 2, you can write that 2. And the derivative of sine x is cosine x. So it becomes 2 cosine x. Then plus, after that, we have just that one. You can copy natural log of sine squared x times cosine x. So you can leave your answer here, 2 cosine x plus natural log of sine squared x times cosine x. Or if you want to simplify one more step, you can do that, because in first term you have cosine x, in second term you have cosine x. If you want to factor that out, 2 out, not 2 out, cosine x out, if you factor that cosine x out, you'll be left with 2 in the first term, then plus natural log of sine squared x in the second term. So that is the derivative of this function y equal to sine x times the natural log of sine squared x. Example, find the point at which the graph of the function y equal to x to the x for x greater than 0 has a horizontal tangent line. You already know the meaning of this one. When we say horizontal tangent line, meaning of that is the derivative or the slope dy over dx is equal to 0. So whenever we see horizontal tangent line, the slope is 0. So here we have the function y equal to x to the x. Let me write that function. Here, y is equal to x raised to x. Now, if you want to find the derivative of this one, now you have to be very careful here. If you want to find the derivative of this one, you cannot use the power rule, because in the power you don't have a number. If there is a number in the power, then you can use the power rule. But both of these are unknown. So if you have unknown functions like this as a power and also the base, what you have to do is you have to take log on both sides. So meaning of that is you are going to do this. You take log on both sides. You'll take log on both sides. log of y is equal to log of x to the x, because this log will remove that exponent in next step. So it will be log y equal to, if you remember the property of log, if there is a power in a log, that power will come in front. That is the property of log. This power will come in front. X will come down, it will come in front. So it can be written as x multiplied to natural log of x. I use this property. If you remember the property from college algebra, the natural log of x to the m, okay, whenever you have the natural log with this type of exponent, the exponent will be coefficient, it will come in front. So it will be m times the natural log x. So I use the same property here. Now it will be easy for me to differentiate. After this, I can differentiate, because what I need is, I need to find the derivative, and that derivative must be equal to 0. That's what I'm going to do. So now this is the implicit function, because y is already inside. Y is no more y by itself. So we have to do the implicit differentiation on the left-hand side. So let me write here, differentiating both sides with respect to x. If we differentiate on both sides with respect to x, I'm doing the implicit differentiation. Derivative of natural log of something, the natural log x is 1 over x. So here it will be 1 over y. But you are differentiating y with respect to x. And you know that whenever you are differentiating y with respect to x, from your implicit differentiation, you know that you have to multiply this by dy over dx. That is equal to, on the right hand side, you have the product. So you'll use the product rule. Product rule says first function x multiplied to the derivative of second. Derivative of natural log x, we already know it is 1 over x. Plus the second function, your second function is log x or natural log x, multiplied by the derivative of first, derivative of x is 1. So if you just want to find dy over dx, if I just want to find the derivative, dy over dx is equal to, if you look at this carefully, look at the screen carefully, here this y is dividing, that's the meaning of 1 over y. If I just want to find dy over dx, I have to multiply on both sides by y to cancel this one. So the right hand side will get multiplied by y, then times x multiplied to 1 over x. X and x cancel, it will be 1 plus natural log of x multiplied to 1 is natural log of x. So we can rewrite this as, my final derivative will be dy over dx is equal to, if you remember what was y, you can see y is x to the x. So in place of this y, I can write x to the x. X to the x multiplied to 1 plus natural log x. So that is the derivative of the function. So far, we are able to find the derivative of the function y equal to x to the x. Now we know for the horizontal tangent line, the derivative must be 0. So we write our derivative, that is x to the x times 1 plus natural log x is equal to 0. And in the question, they have given x is a positive quantity. Greater than 0 means positive quantity. A positive quantity raised to a positive quantity, it cannot be 0. That means the only possibility for this expression to be 0 is 1 plus log x must be 0. So this implies 1 plus log x is equal to 0, because, let me write, as x to the x cannot be 0. So x raised to x is a positive number. A positive number multiplied by 0 must be 0. That means the second quantity, 1 plus log x, is equal to 0. Now, if I want to find the value of x, I need to subtract 1 from both sides. So if I subtract 1 on both sides, it will be natural log x equal to -1 if you subtract it. Then if you want to find x by itself, so x will be equal to If you undo the log, it will be the exponential function. So this is the log with base e, so it will be e to the negative 1. E raised to negative 1. So if you simplify this in your calculator, e raised to negative 1, if you type this in calculator, e to the negative 1, it will be 0.368. 0.368. So we have the x value. So y will be equal to, if you look at the function, our function is x raised to x. Y is x raised to x. X is 0.368 raised to, power is also 0.368 because it is x raised to x. And if we type this in our calculator, it will be 0.692. 0.692. Our x value is 0.368, y value is 0.692. So we can say at 0.368, comma 0.692, the tangent is horizontal. The tangent is horizontal. If you want to sketch the graph of this function, y equal to x to the x, let me show you here. Graph of x to the x for positive x value. If you sketch the graph, your graph will look like this. It is not defined at 0, because if you plug in 0, it will be 0 raised to 0. That's why it is not defined at 0. So we are looking for x greater than 0. So at 0, when x equal to 0, it's undefined. That's why I'm doing that hole there. Then first, this graph will decrease a little bit, and then it will start increasing. So this is the graph of y equal to x to the x. Now, if you look at this graph carefully, a tangent line will be horizontal somewhere here. At this point, the tangent line will be horizontal. And if you want to find that x value, okay, if we come down towards the x-axis, and if you want to look at that x value, this x value is 0.368. So this is 0. X equal to 0.368. And this point, x value is 0.368. And the y value, we just got it, it is 0.692. 0.692. So that is the point where the tangent line is horizontal. Example, use logarithmic differentiation to find the derivative of the following. We may find the derivative of this one using some other technique, but here what we want to do is we want to use the logarithmic differentiation to find the derivative. In part A, we have y equal to the square root. Square root can be written as power half. So I can write this as x minus 1 over x plus 1 raised to power half. That is the meaning of square root. And if you look at this carefully, you can see that you have an inside function, then you have the outside function. You can use the chain rule to find the derivative. But here, we are not allowed to use chain rule because the question says use logarithmic differentiation. So in the logarithmic differentiation, what we do is, if there is any power, we take log on both sides. Like in the previous example, we take log on both sides. So natural log of y equal to natural log of x minus 1 over x plus 1 raised to half. Because this log will now bring that power down. So it will be natural log of y equal to, that power will come in front, half times the natural log of x minus 1 over x plus 1. Now you can clearly see there was no logarithmic function there. Now we have the logarithmic function. And y is already inside the log function. Now it becomes implicit function. So we are going to use the implicit differentiation. So let me write that here. Differentiating both sides with respect to x. WRT, that is with respect to x. What we get is, on the left hand side, you have the derivative of natural log is 1 over the argument, so 1 over y, and you are differentiating y with respect to x, so you have to multiply by dy over dx, because that is the implicit differentiation, equal to half is a constant multiple, you'll keep it there. Now here, it is the chain rule. Log function is outside function, and this is the inside function. So when you use the chain rule, it is the derivative of outside function. Derivative of natural log function is 1 over x. That is the reciprocal. So when you take the reciprocal of this one, x minus 1 over x plus 1, it will be x plus 1 over x minus 1. The fraction will flip when you take the reciprocal. Then multiply by the derivative of inside function, derivative with respect to x of x minus 1 over x plus 1. So next step, we have 1 over y multiplied to dy over dx equal to half is there multiplied to x plus 1 over x minus 1. Then multiply to, here we have the quotient. So we have to use the quotient rule. Quotient rule says denominator, which is x plus 1, multiply with the derivative of numerator. Derivative of numerator, x minus 1. If you want to find the derivative of that, derivative of 1 is 0. Derivative of x is 1. So 1 minus 0 is 1. If you multiply by 1, it will just be x plus 1. Then minus the numerator, which is x minus 1, times the derivative of denominator. Derivative of denominator is 1. So we are multiplying by 1, and the result will remain the same. Divide that by the square of the denominator. So here you have x plus 1. The square of that is x plus 1 times x plus 1. So in next step, I can write 1 over y times dy over dx. This one, 1 over y times dy over dx is equal to, now if I look at the right hand side carefully, here we have x plus 1 in the numerator, x plus 1 in the denominator, and they are in multiplication, so you can cancel, because x plus 1 over x plus 1 is 1. And then, if we simplify the numerator, here we have 1 multiplied to this quantity, which is x plus 1. And then we are distributing this negative sign. So minus x, negative and negative is positive 1. And then in the denominator, if you look at the denominator carefully, here we have, over here, we have a 2. And then we have x minus 1 times x plus 1. If you FOIL this, x minus 1 times x plus 1 is x squared minus 1. Let's go a few more steps here. Dy over dx is equal to, see, here is 1 over y. So in order to get rid of 1 over y, we have to multiply by y on both sides. If I multiply by y on the left hand side, y get cancelled. If I multiply on the right hand side, it will be y times, in the numerator, if you look at the numerator carefully, you have a negative x and positive x. That is x minus x, 0, or they get cancelled. And we have 1 plus 1, which is 2 over, that is 2 times x squared minus 1. Again, when you look at it carefully, you have 2 in the numerator and 2 in the denominator. So 2 over 2 is 1. So we can write our final answer as dy over dx is equal to, if you go back and check the value of y is this one. Y is the square root of that quantity. Square root of x minus 1 over x plus 1 multiplied to, and here I got, these two get cancelled. I have 1 over x squared minus 1. 1 over x squared minus 1. You can leave it here. If you want to simplify, you can definitely simplify a little further. But if you want to leave here, that is totally fine. In part B, we have y equal to x raised to 1 over x. Definitely in this one, you cannot use the power rule because your power is also 1 over x. So we are going to use the logarithmic differentiation. So we are going to take natural log on both sides. Natural log of y is equal to natural log of x to the 1 over x, which is equal to natural log y. So the reason we take the natural log, it will bring this power in front. So it will be 1 over x multiplied to the natural log of x. Now y is already inside. Okay, y is already inside the log function. So we have to use the implicit differentiation. So let me write that here. Differentiating both sides with respect to x. Derivative of natural log y is 1 over whatever is there in the argument. We have a y. And you are differentiating y with respect to x. So we have to multiply by dy over dx. That's our implicit differentiation. Now here on the right hand side, we have the product. So we are going to use the product rule. Product rule says first function 1 over x multiply to the derivative of second. Derivative of natural log x is 1 over x. Then plus the second function, which is natural log x, multiply to the derivative of first. Derivative of 1 over x is negative 1 over x squared. So this implies your derivative dy over dx is equal to, this y is dividing here. So if you want to get rid of this, you multiply on both sides by y. So it will be y times 1 over x multiplied to 1 over x is 1 over x squared, then plus, not plus. This is positive and that's negative. So it will be negative natural log x multiplied to 1. That's natural log x in the numerator divided by, in the denominator, we have a x squared. So this can be written as dy over dx is equal to, now we know the value of y. Y is x raised to 1 over x. So x raised to 1 over x. And also you can see here in the denominator, you have a x squared common. So if you pull that out, that will be in the denominator, x squared. And then you are left with 1 minus natural log x. 1 minus natural log x. Now you can simplify this little bit because you have the same base there. You have x raised to 1 over x, the base is x. And here we have x with power 2. You are dividing, and whenever you are dividing, the power will be subtracted. So it will be x raised to 1 over x minus 2. X raised to 1 over x minus 2, because you have the same base. So whenever you are dividing, the power will subtract. Then that is multiplied to, in the bracket or the parenthesis, we have 1 minus natural log x. So this is the derivative of the function y equal to x raised to 1 over x. So that is the end of the derivative of logarithmic functions.